on the 550-acre construction site of America's newest nuclear power plant, it's easy to see the remarkable progress being made. The module assembly building rises impressively from the flat landscape and stands tall. It's finished and ready to receive components, a few of which have begun to arrive. 200 modules will be assembled here before being put into place. And getting those into place is a project all its own. These cranes you see behind me will be dwarfed by the world's largest heavy lift derrick crane when it's erected here. That crane will eventually reside on what will be a 60 by 60 foot platform situated between the two reactor containment areas. The hook is rated to lift 1,500 tons, and that's what will be needed to put the hundreds of components into place for the two new units. Some parts for the crane have already been delivered here, and it's scheduled to be assembled by the end of the year. The heavy lift derrick crane will place numerous plant sections as deep as 40 feet below ground level into these specially excavated areas that make up the nuclear island. Between the two nuclear islands is the circular platform for the heavy lift derrick crane. The platform has a 300-foot diameter rail track around it. This will allow the crane to place the 1,000-ton sections of the containment vessels and large structural modules inside each of the nuclear islands. The first parts of the crane assembly are being placed on the track right now, and the 560-foot boom is currently being assembled. Welcome back to the construction site of America's first nuclear energy facility to be built in 30 years. This project is historic on several fronts. It's estimated that an incredible 600,000 work hours have gone into just the licensing work for this project so far. Support for the $14 billion construction of the two new units here at Plant Vogtle comes from all around the country. With the COL in hand, the Shaw Group, which is the construction contractor for the project, is ready to move forward, as is Westinghouse, the designer of the two AP1000 reactors.
Right. There's components coming from just about every state in the union.
Our highly trained, experienced, and dedicated employees are committed to reaching new levels of excellence. We remain committed to provide clean, safe, and reliable energy that will sustain and improve the quality of life for our customers and their communities. Here at Plant Vogtle, we're paving the way for the rebirth of nuclear energy in the United States with monumental accomplishments.
Joe Washington.
As we move into the second half of 2012, activity here on the construction site of America's first nuclear energy facility in 30 years is bustling. Almost a city unto itself, the construction site of Vogtle Units 3 and 4 is in full gear. The turbine island is where the massive turbine and generator and associated condensers, pumps, and other systems will be housed. You can see the Unit 3 turbine island, nuclear island, and in the distance, the outline of the cooling towers for both units. The turbine island and nuclear island for Unit 4 show progress on the right. Once assembled, the condensers will be set in place inside the turbine building by the heavy lift derrick crane. Once these giant modules and others are assembled, it's certainly going to require equipment with remarkable strength to move them into place. In previous timeline reports, you've probably seen this enormous heavy lift derrick crane in the background. This extraordinary machine will put the huge modules into place by performing what's called critical lifts. To prepare for these big moves, test lifts were recently conducted here. To tell us more about this, we go to Karen Stoner. She's the project manager in the nuclear division of Shaw Power Group.
A test lift is the actual lifting of concrete blocks to ensure that the capacity of the crane can lift as designed and can do so safely. In this case, the crane was tested at 100 to 110% of its largest lift, which is 1,520 tons. The HLD's first lift will be to take the nuclear reactor vessel off the rail car. The second lift, which is actually the first permanent installation, will be to place CR10 steel on the nuclear island base mat. The heaviest lift this crane will make is CA01 module. It is 1,300 tons, which, to put that in perspective, a school bus weighs approximately 20,000 pounds, which is 10 tons. That means we are lifting approximately 130 school buses. Critical lifts that will be performed are the steam generators, the CR10 steel, the CA20 modules, CA01 modules, and actually the containment vessel bottom head itself. Some of the interesting facts about the crane is that the boom itself is 560 feet tall. This is actually 20 feet taller than the existing cooling towers at Vogel's Units 1 and 2. The back mast is 280 feet tall. There are 8 miles of cable. The cable diameter is 2¼ inches. The crane itself weighs 6.5 million pounds. And the diameter of the rail that the HLD sits on is 300 feet. It takes approximately 20 minutes at full speed with no load for the crane to go full circle. This crane is actually one of 2 owned by Shaw.
Utilizing 2 cranes and a truck transport configuration, Biggie loaded, transported, and unloaded barge sections from the Port of Alameda to Bass Lake in Northern California. At the Port of Alameda, Biggie used a link belt 268 with 105 feet of boom to load the 120,000-pound sections onto our transport rig. This was a 5-axle low bed setup in the front with a turntable and 4-axle dolly with hydraulic steering in the rear. Each of the 4 sections was then hauled 12 hours through a carefully planned route. The load height was 16 feet 10 inches, so navigating through Alameda and Bass Lake roadways while also avoiding electrical wires and streetlights was arduous and time-consuming. The last 5 miles was especially challenging because the route was very tight and narrow and covered with trees on both sides. When Biggie reached the site, we had to back around a tight 90-degree turn and then down a steep hill to the water's edge. From there, Biggie's Liebherr LR 1300 with 125 feet of main boom lifted and set the barge sections onto the shore. This was a large-scale and very difficult job, but with the expertise of our staff, we were able to plan and execute a lift plan and route to overcome all of the challenges. If you would like more information about our transport capabilities, please call TJ Cardin at 510-638-8100 or email him at tcardin@biggie.com. Biggie was on site at El Segundo in Southern California, hoisting and setting heat recovery steam generators on multiple units at a combined cycle natural gas power plant. Our crew performed these lifts using 2 crawler cranes. Working as the main lift crane was a Manitowoc 2250, shown here in blue, with Maxer 2000 attachment and 240 feet of main boom. The tailing crane on this job was a Liebherr LR 1200 SX, shown here in yellow, with 85 feet of main boom. Each of the modules that Biggie hoisted and set were 89 feet tall and 8.5 feet wide. The heaviest of the units weighed in excess of 450,000 pounds. Biggie has an experienced crew and engineering staff who have worked on similar hoisting jobs at other natural gas plants throughout the United States. In this case, our engineered lift plan accounts for the footprint of the crawler cranes within the very limited space of the job site. If you would like more information about this job or you need a quote for an upcoming project, please contact Troy Kussmaul at 510-918-0981 or email him at tkussmaul@biggie.com. At Rodeo Beach in Northern California, Biggie Crane and Rigging transported a World War II-era gun barrel up a steep and winding hillside to a historic battery overlooking the San Francisco Bay. The 120-ton gun barrel was originally a part of the USS Missouri and in place during the surrender of World War II. The barrel will now rest on a permanent display outside of the empty turret area in Marin, where hikers and other visitors can view it alongside the battery. Biggie transloaded the barrel to two 4-line bolstered platform trailers and then used a push-and-pull tractor to navigate the road. It was mandatory that this equipment be used to navigate the steep slope and hairpin turns that provided the only access to the battery. Once at the setting location, a 500-ton capacity gantry with a side shift system was required to offload, side shift, and set the barrel in a tightly constrained location on the hillside. This high-profile job required extensive planning and engineering support. Considering the length and weight of the piece and the grade of the hill, every precaution had to be looked after to ensure the safety of all crew members. Biggie's experience with oversized, heavy hauls allowed our team to complete this job safely and on time. If you have a heavy transport project coming up, please contact Troy Kussmaul at 510-918-0981 or email him at tkussmaul@biggie.com. In Berkeley, California, construction crews are currently in the midst of Phase 2 of renovations on UC Berkeley's historic California Memorial Stadium, host to the UC Bears football team since it opened in the fall of 1923. Biggie has been on site utilizing a Link-Belt HC-278 lattice boom truck crane in a 200-foot taper tip configuration. The crane has been used to hoist precast sections for the renovated seating. For more information on the project, you can visit stadium.berkeley.edu.